Hey, database experts and app developers, do you want to build faster and run bigger workloads? We've got you covered with an exclusive free download of DataStax Enterprise. DataStax Enterprise works with all the latest tools like Kafka and Docker with incredible throughput and the best security. Download DataStax Enterprise for free today by visiting DataStax, that's datastax.com/download DSE. That's the DataStax Enterprise for free. Visit datastax.com/download DSE. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Mark Russinovich. Welcome back to the show, CTO of Azure at Microsoft, and General Raconteur.
Thanks, Scott. It's great to be back. I know it's been a few years since I was on the show last.
Yeah, last time I was talking to you, you had written a book, and now it's a series now. Is it a trilogy?
Yep, it's a trilogy. The last edition of the trilogy I released in 2014, so it's been a while since even that.
Mm-hmm. Well, now you got to turn it into a trilogy of trilogies like Star Wars and do 9, right?
Great idea. Yep.
So what I wanted to talk to you about today is this thing called Dapr, D-A-P-R, Distributed Application Runtime. Folks can check it out at dapr.io, and I'll make sure to include show notes to anything that we talk about or mention during the show here. It says an event-driven portable runtime for building microservices on cloud and edge. That's a very small number of words, but it tries to say a lot right there in one short sentence.
Yep, and I think there's even more you can say on top of it. So we had to be very careful about which words to pick to emphasize the core value.
Why is that?
Because it's lots of different things, and you can use it in lots of different ways. I think that's why we call it really a programming runtime platform rather than a programming runtime, really because you can choose to adopt it piecemeal. You can choose to integrate it into an existing, what people would consider a legacy app or a monolithic app. You can choose to go full bore and take advantage of the pure cloud native serverless aspects of it and create a massively distributed, very fine-grained microservice-based application.
Mm-hmm. So when I hear the word runtime at its base, I think about management. I think about like a womb or a cradle that holds my application and does stuff for me. So at the most simplistic, whether it be Node or Java or .NET, the runtime handles stuff that I'm not interested in handling. Like, the basic example would be garbage collection. I don't want to do that anymore. So you do that thing and I'll focus on these other things. Is this a runtime that does stuff so I don't have to think about those things?
Absolutely. In fact, that's kind of where the logo that came along with Dapr, where we've got the top hat and the tie, Dapr dresser, but also kind of a Dapr style butler that handles things for you that you'd rather not spend your time on, so you can focus on your app.
So it's your application concierge.
Exactly. Yeah.
Okay. So this is primarily in the context of microservices. Is it only a Kubernetes thing, or is it an anywhere thing?
In fact, there's no direct connection to Kubernetes other than we've got built-in support for deploying it onto Kubernetes. You can install it anywhere. So it runs in self-hosted mode. So you can put it on your own dev box. You can put it in a server, a virtual machine, or you can deploy it to a Kubernetes cluster or to any other kind of orchestrator you want. We just have to have, like I said, built-in support for deploying it into Kubernetes.
Mm-hmm. When I'm making an application, I think that we sometimes blur the things that we need to solve the business problem, and then all of the kind of cross-cutting concerns. So it's like, hey, we're going to make a website, session management, authentication, authorization, and on, deserialization. There's a whole list of stuff that has nothing to do with what we do here at Acme Insurance. And sometimes we blur the line and we end up writing all of these other things just because they don't either exist or the ones that exist don't do what we want them to do. Is the stuff in Dapr trying to be completely supportive? It always plays a supporting role for me to not have to write something and then I do the business logic separately and entirely separate from those cross-cutting concerns?
That's its goal. And in fact, it was basically inspired by what we saw happening in cloud native programming models like functions as a service and actor models. And really the primary goal of Dapr was to bring cloud native distributed microservice application development to enterprise devs. Many enterprise devs are familiar and skilled with and everyday writing traditional multi-tier web plus database apps. And learning all the things you need to learn to build the distributed microservice-based app is a lot of complexity and a lot of different SDKs and a lot of concepts that distract from, like you said, focusing on the Acme problem that they are paid to go solve. And so just like functions as a service takes and performs a lot of things on the developer's behalf so they don't have to worry about it, Dapr takes that idea and takes it forward.
So in the docs and in the README, it says Dapr codifies the best practices for building microservice applications. But then you said that it explicitly doesn't target Kubernetes or prescribe. So it sounds like you're kind of walking the razor's edge between being prescriptive but also being flexible. Is that difficult to not like hold it down and say, this is exactly how you should do everything versus the cafeteria plan?
Not really, because I think one of the benefits first of Dapr is it's extremely extensible. So when we say codify best practices, the best practice can depend on who the customer is, what the target workload is, the requirements around the application. But you can codify best practices for classes. And if the codifications that are built into Dapr and the ones that come with it don't meet your needs, you can codify your own. So take, for example, back off and retry when it comes to interacting with another service. There's best practices for how you do back off and retries that as a developer, you don't want to spend your time implementing that in your code. And so that codification of those best practices can be in Dapr itself, so that when you call into Dapr and say, I want to talk to this remote service, Dapr is taking care of that complexity.
It's 2020, and why hasn't this stuff happened before? Like, I was joking. I was giving a talk recently, and I joked about how long my resume was. I said, I got a 3-page resume, but page 2 is just learning to scale a web farm. And then, at some point, page 2 of my resume got ripped out because scaling a web farm is pretty much just a slider bar now. Like scaling out is pretty much understood. It seems a little bit late for us to be like saying, okay, can we all just agree on how we manage secrets? Can we all just agree on how we manage state? Is this just a matter of like one additional standard?
Well, I think the various parts of this have emerged in different runtimes and programming models already. I think what Dapr brings to the table is this sidecar pattern. With the sidecar pattern and the focus on solving these distributed systems problems that come as part of the territory when it comes to cloud native development, it really is opening up the door for a very flexible, extensible runtime that hasn't existed to this date. And once you start to look at Dapr, it seems like the obvious kind of stuff. It's just that I think that when we looked at the problems that we wanted to solve, that Dapr emerged as the solution to be able to solve them.
And that sidecar concept, that sidecar architecture is really fundamental. This isn't a thing like I had used the example of a cradle or a thing that is a runtime that is holding your code, but your application code is the motorcycle in this context. And Dapr is the sidecar. It is lateral to your application. And in doing that, it gives you full flexibility. It's not prescribing it so much that it smothers it with recommendations.
Yeah, exactly. And that's what really makes it so that you can incrementally adopt it or fully adopt it, depending on what your needs are and what you want it to do for you. So just one example, on one side of that spectrum, you can say, you know what, I like Dapr's actor model. And so I'm going to use Dapr actor model SDK, which provides me language integration convenience with the Dapr sidecar, where the actor interfaces are actually implemented. And now I'm taking advantage of Dapr for service discovery, invocation, messaging, state store, basically most of the underlying building blocks or services that Dapr provides. On the other hand, you could say, you know what, all I want to do is use Dapr to talk to Kafka service because I don't want to worry about all the complexities and integrating with the Kafka SDK. So what I'm going to do is talk HTTP to the Kafka sidecar and the Kafka binding that it supports. Mm-hmm. And now I'm taking advantage of the best practices that are built into Kafka binding. I don't need to include the Kafka SDK or the client libraries or code or get the right SDK for my language into my code. I can just leverage it directly. And so if Kafka only supports, it doesn't have a Rust SDK, for example, but I want to write my component in Rust, mm-hmm. I can call into the Kafka sidecar, which talks to Kafka for my Rust code.
In bringing the actor model into it, doesn't that kind of like, that's a little bit more main course than the other core concepts that are included? Like something like, oh, here's how we do secrets and here's how we manage service invocation seems of a certain size. And then it's like actors, that seems more prescriptive.
Well, it is a little bit more prescriptive. But even there, Dapr is flexible in what it provides from an actor model perspective. But really where we started from it was saying serverless. Mm. What is serverless? What makes it easy for enterprise developers to write a cloud native distributed application? And that's where we took a look at what was out there. And from our learnings with Azure Functions and Service Fabric Reliable Actors and talking to customers and seeing what they were doing with it, recognizing that, like I said, enterprise devs want to focus on their app, not on all these complexities of distributed application and state management, service discovery and invocation and triggers and backoffs and retries. We said, hey, if we go with the sidecar model, we can actually support a serverless, a functions as a service type programming model if a developer wants to use that. We can actually support with a little bit of extra code, like keeping track of actor invocations and doing the virtual actor state hydration and dehydration, that we can build an actor model on top of it. And really then at that point with functions, the basic function support and basic actor support with degrees of flexibility for both of them, depending on what the developer wants. Now we've got basically a holistic programming model platform that supports stateless scale out microservices as well as stateful microservices. Mm-hmm.
What does it mean, though, in the context of all the other actor frameworks, whether it be Orleans or Akka and et cetera, et cetera? Like there's co-opetition and certainly competition in these different things. Is this as prescriptive as those other actor frameworks?
It's not as prescriptive as those other ones. For one thing, it separates the underlying cluster or management mm-hmm. from Dapr. Dapr doesn't provide that. Okay. What it does is just keeps track of where actors are. So it's got an actor service, management service. Mm-hmm. But the reason that it's less prescriptive is that, for one, it is language agnostic. Mm. And if you take a look at the actor models, programming models that are out there, they typically are Java and C#, and that's it. Mm-hmm. But you could write an actor for Dapr just using the HTTP or gRPC interfaces in whatever language you want, including, like I mentioned, Rust. And so it's less prescriptive in that way. Like I said, you can have language SDKs that make it easy for you to inherit from some base class, so you don't have to implement that yourself mm-hmm. if you want to, but you don't have to. And the second way it's less prescriptive is that we've got built into it ways that you can control the concurrency model on it. So if you say, well, if you take a look at the reliable actors like Service Fabric Reliable Actors, it had a strong concurrency model, which most developers want, which is when you invoke my actor on a method, that method should be serialized with respect to invocations of that same method or any others that are part of this actor class. With Dapr, you can relax that and say, you know what, I want really high performance, so I'm going to take care of synchronization myself. I'm going to put locks into my code so that I can create these critical sections that are only necessary, that are just to protect the state transitions that I've got, but otherwise let things run in parallel. And so it also is more flexible from that perspective.
Hey friends, you know how I love great podcasts, and I want you to check out the Code Newbie podcast. It's all about stories from folks on their coding journey. They talk to new developers, experienced developers, and everyone in between about how they got started learning to code, how they navigate their technical careers, and they also do deep dives into technical topics in a newbie-friendly way. Check out their podcast at www.codenewbie, that's NEWBIE.org/podcast. That's codenewbie.org/podcast. So you've pulled aside a lot of implementation details like input-output bindings. You can pick Kafka or AWS or GCP or whatever. Your state store has been pulled aside. It's non-denominational in its religious choices, and you're non-denominational in your publish and subscribe. Can you maintain perf when you are so pluggable with some of the basic stuff?
Yeah. Good question. So I think this goes with the flexibility of Dapr. So with the standard bindings that we got, for example, for Kafka, if you decide that binding doesn't provide you sufficient perf, you can write a different binding. Nothing stops you from writing your own custom binding for that service or any other service. But at the same time, nothing stops you from directly using an SDK for a service in your code. So if you don't want to use Dapr to talk to Kafka, you can talk to it directly. Nothing gets in your way. It's just there as a convenience layer. And one of the benefits of it is once you have these bindings, the ecosystem is contributing to them. If you want to improve them, you improve them, and everybody takes advantage of them. And not only that, but the binding that you write for Kafka applies to somebody writing a function on top of Dapr, or somebody writing an actor on top of Dapr, or somebody that just wants to talk to Kafka directly from their existing web app through using Dapr. So it's this one place where you can concentrate and magnify people doing innovation or providing improvements in performance or security.
So let me up-level and back up in time a little bit. There was a time when we would talk about chatty interfaces and chunky interfaces, and we would talk about in-process calls and out-of-process calls, and then we would ask ourselves, when does this thing hit the network? So in-process, out-of-process, out of machine, and then now we're thinking about things in terms of, have I swapped over to another pod? Have I swapped into another rack? Am I suddenly now talking to another data center? How often does the business logic person that we were trying to target here have to think about those things and like, oh, I've just hit the network and now perf is gone all to heck?
So nothing can, take away the fact that for many scenarios you're going to be concerned and have to worry about locality, like you just talked about in the crossing of network interfaces, how many hops you're taking. Again, the idea is Dapr doesn't get in the way of you doing those optimizations. So when you place your microservices, that is, so Dapr will take care of it through the actor model. But other than that, you've got control of it. So where your microservices get placed, and so you can control how many hops it's going in from where to where. That is an operational decision, and I think it's important to separate that from the code that the developer writes. And one of the reasons you see us talk about Dapr, the runtime for the cloud and the edge, is that we see a world emerging where you're going to have apps that span the cloud and the edge. And one of the benefits that the sidecar pattern gives you with this local HTTP endpoint is that you can talk to services, and you don't, from a developer and the code that they write perspective, don't have to worry about where that service is. It could be sitting there if I've got the microservice executing hosted on the edge, and it talks to the Dapr sidecar and says, I want to talk to this other microservice. Dapr takes care of the routing, and that could be sitting there on the same server. It could be sitting on another server out on the edge, or it could be up running in the cloud. And the code is going to work the same. And so I can move these microservices around to suit the latency and bandwidth and reliability requirements of my application scenario, but the code doesn't have to change.
And forgive my ignorance, but it's worth pointing out to myself and to the audience as well that so the Dapr runtime is definitely multi-instance. It's not like it's a central sidecar. These sidecars can go all over the place. They're multi-instance throughout your application.
That's right.
So then you could have the Dapr runtime on the edge, and maybe take a moment and explain, because everyone hears that term edge a lot and it's very overloaded, but explain what that means to have your application exist and live on the edge.
Yeah. So the edge, when you talk about the edge, you're talking about relative to something. In this case, we're talking about the cloud, public cloud. And so everybody, I'm sure, is familiar with hosting applications in a public cloud like Azure. When you're talking about the edge of the public cloud, that means devices that are outside of the main Azure data centers in this case. And so that could be a Kubernetes cluster that's sitting in your own data center. It could be, in that case, it'd be hybrid rather than technically edge. It could be a Kubernetes cluster sitting in a building that's a smart building where it's controlling HVAC or lighting or conference centers, conference rooms. It could be a server or a Raspberry Pi sitting in a retail store. That would be all examples of edge computing. And the reason that they're edge is that they're communicating with the cloud. They're getting typically control and software deployed from the public cloud. There's different variations on the topologies for how a device gets connected up in the public cloud. There's also different kind of configurations for how they're connected, whether they're directly connected, constantly connected, occasionally connected, or disconnected with some kind of air gap way to get the code and the telemetry and data back and forth between the cloud and the edge.
Yeah, I really like the example of like a grocery store. Like if I managed a big grocery outlet and I'd have our central cloud that was maybe partially in our own data center, but largely in a cloud like Azure. And then, we don't want to count on anything. We don't want to assume anything. So we'll have our own Kubernetes cluster running in the actual, local grocery store, so that grocery store could be offline for days even, and still people would be able to buy food, batch everything up, and then it would be sent off when we got back our connectivity to the central location. You could phone home, like you said, so occasionally connected, or at least resiliently connected. And then if you inject Dapr into that sidecar would run in any and all of those locations, providing all the different services and core concepts that Dapr offers, whether it be in the self-hosted cloud, in the actual public cloud, or running on the edge, or even, like you said, in tiny devices themselves. And because, if I understand correctly, Dapr just makes the assumption that as long as your code can speak HTTP or HTTP2, it can do protocol buffer encoding, because it's all HTTP and gRPC, really anything could talk to Dapr.
Exactly. I mean, I think, what's so powerful about this is exactly that it, like we've been talking about, really summarized, is Dapr provides all these building blocks. You can compose a la carte, or you can compose them in big chunks to get things like the functions as a service model or the actor model. You can consume them from any language, from any app, from any existing code, because it's anything that knows how to talk HTTP or gRPC can immediately take advantage of some or all of it.
Do you think that in some theoretical future, a year, 2 years down the road, that if, just like Apache and then followed by Nginx and then perhaps something else becomes so ubiquitous that it becomes the fabric of the internet itself? Like there was a day where Apache wasn't around, and poof, then everything was running on Apache. And then within a few years, Nginx just took over. And then within a few years, Kubernetes is taking over. If we start to up-level like that, would you see a programming language or programming languages start to optimize for the sidecar pattern, to optimize the way that we express our code and our intent for HTTP, for gRPC, and then for something like Dapr itself? Because if you're going to roll your own, you're still going to be basically making these HTTP calls yourself. And some of the languages are a little bit more chatty than maybe they need to be. Could we hide a lot of that and write a language itself that could speak to a cloud native actor runtime?
Yeah, I definitely think that you're going to see language optimizations for talking HTTP or gRPC. I think, though, that, and this is one of the recognitions that we had looking at functions as a service or actor models where they only support a subset of languages, and the fact is that languages proliferating like crazy, is that there's not going to be one language that's going to be the one to rule them all, or even 3 or 4. And the number that we have to support in Azure and our SDKs continues to grow as new ones become popular. And so, yeah, you're going to see those optimizations, but I think there's not going to be this is the programming language for distributed application development. It's going to be everyone is going to end up with optimizations and support for it.
So the essence of Dapr is really non-denominational. The SDKs now have Go, Java, JavaScript, .NET, Python. The developers never really have to deal with gRPC and HTTP. So the SDK largely handles a lot of those abstractions. So while there might be some potential future language that is optimized for something like Dapr, there's really no need to do that.
That's right. And I think that the fact is, like we've just said, that there's some language convenience SDKs for Dapr, but a new language comes out, the Scott Hanselman language that you developed, that's great and optimized for web development. That you can immediately start integrate that with Dapr because you don't need an SDK for Dapr to integrate your language with it.
One of the things that I've been finding, the larger my systems get and the larger that the systems that I consult on get is, it's still just text files, except now there's 1,000 of them and I have to bring all of those together. I kind of felt like I'd have a jetpack right now, a self-driving car, and I wouldn't be regexing through text files. But the distributed tracing is a big part of Dapr, and it integrates with OpenTelemetry. Maybe you could speak about that for a second.
Yeah, so I think because Dapr is sitting there at a sidecar, and once you start integrating with it, your application traffic is going through Dapr. Dapr has this great position to be able to log activity for you and for you to get a distributed view of the way your application works. Some people that are listening probably are familiar with service meshes, and service meshes are the same thing, but at the infrastructure layer. What Dapr you can think of as an application layer service mesh. And just like infrastructure service meshes that can log network traffic and impose policy, Dapr provides that same kind of control point for application level inter-serve microservice communication. And one of the components that we built off the bat to take advantage of that is the distributed tracing building block. And once you opt into that it's collecting and emitting the Dapr traces of microservice interactions in the OpenTelemetry format. And we've got, I think, 7, there might even be more than that, different tracing systems that now are plugged into Dapr. So Azure Monitor is one example, or Application Insights. And so now you can, just by flipping a switch, have this data emitted and then viewed in Application Insights and see the execution of your microservices, how they're talking to each other, where there's latency, where there's failures. All of that basically comes for free just by using Dapr.
Yeah, there's Azure Monitor, there's Datadog, who has been a sponsor of this show before, and Jaeger and SignalFF, and on and on and on. So basically, all comers. And again, if there's not one, as you've said before, you can plug in your own.
Yeah, and I when I think about, okay, so what would stop Dapr from somebody from wanting to use Dapr? I really struggle with a reason, because all the kinds of excuses that we've seen for why can't you adopt functions as a service? Why can't you adopt the actor model? Why can't you adopt some special purpose runtime that's providing something? All of those reasons why you might not be able to adopt something are gone, and the benefits of taking advantage of this open ecosystem flexibility and the portability are all there as part of the value proposition. So it seems like a no-brainer to me. I struggle with the why wouldn't I use Dapr?
Well, what if you are starting to feel like things are getting so broken apart that it's time to go back to the big ball of mud monolith? Like, are there any challenges in this ecosystem of all these open source projects, and everything's moving so fast and everything's being versioned so fast? Have you had any challenges? Has your team had any challenges in putting this together where you found something was not as robust as it should have been, or maybe you bet too much on this or that, or gRPC is not able to keep perf up to the point that you want it to be? What are some things that aren't a slam dunk in all of this microservices architecture?
I think that, so for one, building on industry standards, I think, means that we can ride the industry, the ecosystem's innovations around things like gRPC or HTTP for that matter, and HTTP servers. So as far as reasons you might not be able to or want to use Dapr, we touched on them a little bit earlier when we talked about performance, where I want performance. For example, I want to pack microservices, many of them, into the same process, and Dapr doesn't support that today. Or I want no hop across an HTTP or gRPC interface to get out to the network. I want to access it directly. That might be another reason. So there are potentially some cases where you might not want to, but even in those scenarios where you got an application that needs to have some optimized path through it, it's most likely that there's many other paths, many other services that using Dapr is just fine. So again, this ability to take advantage of it in part or in whole or whatever pieces of it you want actually makes it so that saying Dapr is not good enough, again, I don't think is a blanket statement that I'd ever can imagine somebody saying, because Dapr might not be good enough for this one particular aspect of my app, but there's many others that I'm sure it would be.
Well, it seems like that, HTTP and gRPC and the concept of RESTful APIs and now microservices and Kubernetes and all of the different supporting things that would be required to make something like Dapr and you, the listeners' application successful. The time has come, and it is the right amount of maturity, and that people should really explore these architectures.
Yep, that's right. I think that this is kind of the next step on the evolution of cloud native, building on all of the fundamental work that has been developed over the last 5 to 10 years. And we're going to see more on top of this. I'm sure Dapr's not the end of the story, but it's, I think, a fantastic new level that it's a productivity that developers are going to get to with it.
Well, folks can check out Dapr at dapr.io. You can install the CLI on Windows, Mac, or Linux. Check it all out. There's extensive documentation. There is a burgeoning and excited community and a ton of things that you can plug into it. And again, it's a cafeteria plan, so certainly you don't need to do it all. You can just take the pieces that you want. Follow it on Twitter. I'll put links to the Gitter community chat, and it's actively being developed, so pull requests are welcome. Thank you, Mark Russinovich, for chatting with me today.
Thanks, Scott, for the time. Hope I've made you a Dapr fan.
I will go and check it out immediately and try to build it out on my own machine and see what the kind of solutions that I can build with Dapr. This has been another episode of Hansel Minutes, and we'll see you again next week.